The calendar for the plan that we have forward for the month of April into first week of May. Okay, so we have trigonometry being starting today, and then we're gonna start unit circle next week, and then we're gonna work on unit circle every day. I'm leaning towards no index cards because these are facts that you need to have memorized going into trig. Okay, even if you're not going to trig, these are basic math pieces you need to have ready before you go to college. Okay, so we have the unit test scheduled on April 30th for you guys. Okay, on the 2nd of May, what I'm going to do is I'm going to give you guys, those of you that are moving into trig, you're going to have an opportunity to learn one more topic, which is essential for you to know before you get to trig. All right, so the prerequisite is something you should already know from geometry. The lesson order is listed there, so you know. Now, when we get to the practice page and the Delta math part, what I'm going to do is I'm going to give you an option. You guys notice that I haven't been checking your homework, right? It's all on you. It's been 100% on you to whether you get your homework done or not. It shows up on your test scores, right? So I'm giving you a choice between the two types of practices. The online one, where you could do the work on the separate sheet of paper and do it however way you want to. It even includes videos and examples and guidance, whatever you need on Delta Math. Or you could just do the practice pages that I indicate from your packet. You choose. You could do both if you want. You could do one or the other. You could do part of one thing and then do another part on this one. It's up to you, okay? But I figured having multiple types of modes that you are more comfortable with will give you an option to choose which kind of homework you can use to best benefit yourself, okay? We're only doing the prerequisite and lesson 1, 7-1, learning target. And then next class, we're working on radian measures, okay? So we'll go over that on Friday, and that's it. Questions?
Wait, it says on the paper, Unit 7 test date.
Oh, test date. Let's fix that. The test date is incorrect. So is April 30th for you, which is a Wednesday. Okay. And for the other classes, it'll be May 1st for Thursdays. Through probability in first half of May, probability and stats in first half of May, and then the rest of the May month, we're going to do taxes. And then math fluency, possibly 2 more. Okay? One more unit test for the trig, and then another unit test for stats and probability, and then I think 2 or 3 fluency quiz. Okay? Yep. So instead of starting at the very top, we're going to start on the bottom because this part is something that you should have from geometry. Okay? So we're going to tap into what you already know or should know. And if you don't, then this is a great time to learn it right now. Okay? So we're going to start here at the very bottom. When you have ratios, what is a ratio? What's a ratio? Comparison of 2 or more values. Yeah. So these are the most common angles that you're going to be working with. In a given triangle, what do all the angles add up to? 180. No matter what kind of triangle it is, it's going to add up to 180. We know that this is what degree? 90-degree angle. Okay. Then the other 2 angles that are part of that same triangle are going to add up to 90 degrees, which makes them what type of angles? Complementary. Remember those? Yes? Is it coming back at all? Complementary angles are angles that add up to 90. Supplementary add up to 180. Okay? So, I'm erasing that. Those are just review, okay? The angle that is opposite to 90-degree angle is the diagonal right here. And we call this hypotenuse. Hypotenuse. Hypotenuse, okay? Hypotenuse, okay? Hypotenuse is the diagonal the side that is directly across from the right angle. It should not be touching the right angle at all. When you say opposite, we're talking about directly opposite. So if I were to say, who is opposite to Joseph, it would be Isaac. Okay? Who is adjacent to Joseph? Joshua, Doe, and
Megan, right? So we got people on the sides to Joseph, and then we got someone that is across. If this is, let's say that's my Joseph angle right here, 45 degrees, okay? Right here, that's called the angle of reference. From that, it's from this person's POV, okay? This angle's POV is going to be opposite side is this leg right here. This leg is your opposite leg, okay? Then which one is adjacent to this angle? The one that is right next to the person on the ground is the adjacent. Okay? Are we clear on these terms? I'm going to be using it the whole period. Opposite, sorry. Opposite. I don't know. I forgot how to spell opposite for a second there. Okay.
Can the opposite and adjacent be switched since it's the same angles?
In this case, yes. But in 30, 60, 90, no.
So if it's like symmetrical, you can.
If you know for sure, these two angles are identical, yes. But if you don't know that, you cannot assume so. Okay? Never assume anything on any figures that you're given. Okay? Never assume. Okay. And then right here, 30, 60, 90. I'll do that later, actually. Okay. So the ratio, like, I don't know. How many of you guys have grandmothers and grandfathers who cook? Yeah. Okay. Do they ever tell you, like, how many cups of this, how many spoons of this, like, actual measurement of teaspoons and tablespoons versus cups and whatever? No. No. This is what they do. One handful of this, one bowl of that, and then one bottle of this, and then we're done, right? And then it's done. It's just love is the rest of the recipe. Yes? Okay. That's a ratio. In this case, if you have a 45, 45, 90, it's always this angle. If it's the same as this angle, the sides are also congruent. They're also the same. So if this is 1, then the opposite to this angle is also going to be 1. So it's 1 to 1. Okay? So this side is 1 to 1. Then the hypotenuse is going to be rad 2. And that's based on Pythagorean theorem. 1 squared plus 1 squared is 2. Square root of 2 is square root of 2. Okay? Now, if I said, instead of 1, what if I said x? This opposite side to this reference angle is x. Then what can we say about the blue side? It's also x. And if that's also x, then what's the hypotenuse? X rad 2. X times rad 2. Okay? So those of you that's too abstract for that one, this is what you do. Okay? Let's say I have a 45, 45, 90 triangle, and this side is 5. Then what is the adjacent side to that reference angle? What's the side angle? 5. And then this must be 5 square root of 2. Does that make sense? Any questions? Okay? Okay? All right. So, I think that's it. Next thing we need to remember is an acronym, a mnemonic, that helps us remember the ratios. Okay? So SOHCAHTOA is the oldest trick of the hat kind of remembering, like mnemonic that math teachers have used forever. Okay? Even my math teachers use them, so it's really old. Okay? So if we have SOHCAHTOA, is to help you remember the first letters of each part of the ratio you need to remember. Okay? So S is for sine of any given angle is going to equal opposite to hypotenuse ratio. Noman's going. Come back, Noman. Okay. All right. Ka is going to be CAH, where cosine of theta is equal to adjacent over hypotenuse. And then the last one, tangent, TOA, is tangent of opposite, tangent equals to opposite over adjacent. Theta equals to opposite over adjacent. Okay? Are we doing okay? Review? Yes. If you have your computer out, can you please put it away? You don't need it right now. Okay. So sine of 45 degrees. Okay? Do you have your calculators? Go get the calculators. You're going to need it. Go, 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 go. Boys, get your butts up. Go get it yourself.
Alex, can you get 16, please?
I'm not 18. There's no 18. But I am 18.
You know, did they rehearse them? The southern accent killed me. I was dying. Where was 17? In someone's backpack. I don't want to say. I'm not going to say. Because if it happened to you, I wouldn't want to say it too. Right? No, it wasn't this class. It was the most unexpected class. So, yeah. All right, you ready? It's okay. As long as it's found, I'm okay. How are we doing? Okay, I need everyone to turn it on and reset. On, and I want you to do second function plus 712. And clear those rams. Okay? Second function plus 712. Okay? You should say ram clear. Are we good?
Yeah.
Okay. And then if you hit enter, it'll clear the screen again. Second function plus 712. And it should say this. Okay? Are we good? Did we all do it? All right, guess what? I'm going to do something with you that is going to blow your minds. All right, here we go. We're going to tap in sine of 45. Okay, sine of 45. And you're going to get a value. Okay, now pause. Don't do anything after that yet, okay? I want you to write down the ratio before we go back to our calculator, okay? So what's the opposite? Because it's sine, we need to get opposite over hypotenuse. So I'm going to do 1 over, opposite is 1, so 1 over square root of 2. Okay, back to our math fluency. If I have a square root in the denominator, what do? You have to rationalize it. This is like a geometry student's answer. Are we in geometry? No, we're in Algebra 2. This is the Algebra 2 answer I'm expecting. You ready? You're going to multiply this to get rid of the rad 2 in the denominator by multiplying rad 2 over rad 2. That will not change the value. It just changes the outfit, the way that 1 over rad 2 looks. Okay? So that becomes 1 times rad 2 is rad 2 over rad 2 times rad 2 is rad 4, which is 2. That should be your answer. Algebra 2 answer in red, geometry answer in 1 over rad 2. Are we clear on this expectation? So if you decide to write 1 over rad 2 and leave it like so, expect it to be at most a 9 if it's correct. Okay? It will not be a 10. If it's not rationalized, you will not be getting that 10. Okay? So in your calculator, I want you to put in square root of 2 and then push yourself out of that radical sign, put divide by 2. Huh? Shouldn't that be identical? Yeah. Square root of 2 divided by 2. Here, I'll do it on my screen right here. Hold, please. Please hold. Come on. All right. Camera, please. Boop. All right. So I told you to do sine of 45, right? Oops. Delete. 45. And we got a value of 0.8509, right? And then I asked you to do what? Square root of 2. Move the arrow, the cursor out of that radical sign. Hit divide by 2, which is the ratio we wrote out from the paperwork that we just did, right? They should match, agreed? They don't. Guess why? Go to mode. This is the mode. It's in radians. You need to change it to degree. Okay? Change it to degree. And then do second, hit enter to select degree. Second function mode is what you want to do. What do you need, Nathaniel? Now try sine of 45. See, I told you, mind's blown everywhere. It's like a minefield. Oh, mine's being blown. Okay, so here's the thing. Did it give you like an error for using sine of 45? No, it didn't give you an error. It gave you a value. Could you easily just write down that value and think that you have it right? Totally. And I don't want that for you. When you start the test or homework, I need you to make sure your calculator is not in radians, but rather degrees. Okay, if you have a scientific calculator, the mode still changes it, and you can see it. It's at RAD for radians or DEG for degrees. Change it to degrees before you start any trig homework. Okay, if there's an angle that is given, then that's in degrees. You want to use degrees. If it's given to you in radians, use radians. Okay, any questions so far? All right, I hope that was clear. Okay, so keep this out. Hold on to it. Keep it in degrees. Keep it in degrees for now. Okay, we're gonna go back to our notes. Let's try cosine. Is cosine going to be any different than sine? It's adjacent over hypotenuse. What's the adjacent's length? 1. The ratio of adjacent is going to be 1 to rad 2, right? That looks the same to me as sine. What's it going to be? Rad 2 over 2. Okay? Tangent. That one's going to be probably different. What's the ratio? Which sides should be in my ratio for tangent of 45 degrees? Opposite over adjacent. So opposite is 1. Adjacent is 1, which simplifies to 1. Yay. Okay? How are we doing? Make sense? Okay. 30, 60, 90 is a little tricky, but it's not hard to memorize. Okay? 45 is always 1 to 1 to rad 2. 1 to 1 to rad 2. If you remember the two legs are identical and it's 1 to 1, you can just add those, put square root of 2 on your hypotenuse. Okay? Figure out a way that works for you to memorize these triangles. I figured out mine. I'm sharing mine, but you don't have to take mine. Use whichever way that you can remember both of these triangles. For this one, this is how I remember it. Remember I told you, like, if this angle is same as this angle, then the two sides that are opposite to those angles are going to be identical, right? If this is smaller than that angle, if 30 is smaller than 60 angle, the sides that are opposite are also going to be smaller for 30 and bigger for 60. Okay? Are Are we okay so far? So we start with opposite of 30. Opposite of 30 is going to be 1. Okay? Just because you double the angle does not mean you double the length. Just because you double the angle does not mean you double the length. It's just that it's bigger than the first angle. Okay? This hypotenuse is double. So the hypotenuse is going to be double. Okay? Are we doing okay? And the side opposite to 60. So that will be, shoot, I did it in opposite colors, didn't I? Sorry. Let me change it to red. And I'll change this to blue. So adjacent side to 60 is going to be rad 3. Adjacent side to 30 degrees is rad 3. Okay? 1, 2, 3. 1, 2, 3. Square root of 3. Okay? 1, 1, 2. Rad 2. Okay? I'm trying to give you like different ways to remember them. Okay? 1 is the opposite to 30, and it's going to be double. You're done with your test. Where did I lost it? No, just kidding. It's right here. You know what to do? Okay. Go. Yeah. All right. So rad 1. Sorry, 1 is the opposite. 2 is the hypotenuse. Rad 3 is the adjacent. So sine of 30 degrees. So which one is my angle of reference? 30 or 60? 30. So from here, which one is my opposite side? 1. So I can make a little mini triangle graph if you get confused about all of those pieces that are there. I always like to rewrite my own little triangle, and here's the reason why. When you get to the 60, it gets a little confusing that you have to use the same 30-60 at times. When you're overwhelmed with the test, you want to have 2 separate triangles just because you're going to get adjacent, opposite confused, according to which reference angle, okay? So I like to keep my reference angle at the bottom right. I like to keep my reference angle at bottom right, so I just redraw all my triangles so that way I can keep my mind like same every time I see it, any triangle, because all these triangles are going to be flipped around, turned around, sideways, upright, flipped over, whatever it may be. So I like keeping my reference angle at bottom right every time. Okay, so sine of 30 is going to be opposite over hypotenuse. So what's opposite? 1 over 2. Try it for me on your calculator, sine of 30. You should get 0.5. Did you get it? Woohoo! What about cosine of 30? It should be adjacent over hypotenuse. What's adjacent? Rad 3 over 2. Try rad 3 over 2 first. Rad 3 divided by 2 on your calculator. And then try cosine of 30 and see if you get the same thing. Yeah? Okay. Any questions? Easy peasy? I hope. Okay. Tangent. Tangent is going to be opposite over adjacent. So opposite to 30 degrees is going to be 1. Adjacent is going to be rad 3. So it's going to be 1 over rad 3. Can I keep that rad 3 there? Yeah, if you're a geometry student. Are you? Not anymore. You're algebra 2 trigonometry students. So we're going to rationalize the denominator. And what are we going to do? What are we going to get? Rad 3 over 3. Questions? No? Okay. You okay? Go get one. There's so many. Pick one. You're not even in class right now. Pick one. Okay, you're okay. All right. So again, I want to redraw for my 60 degrees. Instead of keeping it like this, I want the 60 on the bottom right. It's going to be steeper or flatter than 30. Steeper. Angle 60 is steeper than 30. Yes? It's double the size. So what you're going to do is you're going to draw a pretty tall triangle with 60 in the bottom right. Now try to figure out which one's my short side. It makes sense, right? Which one's my short side? Adjacent or the opposite to 60? Adjacent, which is down here, 1. Then what's opposite? Rad 3. Hypotenuse is still the same? 2. The reason I redraw, biggest reason, is to figure out which one's my 1. If you don't redraw this, you might think, okay, 60 opposite is 1 and rad 3, because you're keeping this in your head. Okay, that will be incorrect. So I like redrawing it to find the shortest side to be 1, double the hypotenuse, and it's rad 3. Okay, so what's sine of 60 degrees? Opposite over hypotenuse, right? So it's rad 3 over 2. Done. Okay, cosine. Cosine is adjacent over hypotenuse. Notice something. Do you see how they're identical? And these two are identical? So if you're given sine of 30, can you use cosine of 60 to get the same answer? Absolutely. Okay? If you're given cosine of 30, can you use sine of 60? Okay? So keep that in mind. It's going to come in handy. All of these are things that you can make connections with, become tools that you can use for any kind of trig questions. Okay? So tangent of 60 degrees, opposite over adjacent, which is in blue. So opposite is rad 3 over 1, which is rad 3. All right, so trig function is a rule defined by a trig ratio. Okay, so we're going back to the top of the same page. We're going back to the top of the same page to start 7-1. Okay? Trigonometric function is a function whose rule is defined by a trig ratio. A trig ratio compares the lengths of two sides of a triangle. Okay? Trig ratio is always with the right triangle. Okay? The Greek letter theta is used to represent the measure of an acute angle in a right triangle. A triangle with a right angle is going to have two angles that are acute. Does that make sense? Okay, so with this, I really didn't like ABC written there, but I'm gonna keep it just so that we can keep it consistent with the picture. I'm going to label it though with, what colors do we use? Red and blue, okay. Red for opposite. So if this is our reference angle, this is our opposite side. Yes? And if this is my reference angle, then B is my adjacent side. Then the side that connects the opposite to adjacent is my hypotenuse. All right, so which one represents the sines ratio? Sine of theta is equal to SOHCAHTOA, opposite over hypotenuse, which in this case is represented by A over C. Does that make sense? Okay. Cosine to this theta's angle is going to be adjacent over hypotenuse. So adjacent is B over hypotenuse is C. Okay. All right, tangent. Opposite over adjacent. Opposite over adjacent. So that's going to be A over B. Okay, now cosecant, secant, and cotangent are reciprocals of each of those trig functions. So reciprocal to sine is when we take this and flip it over, right? Yes, it's same thing as saying putting sine in the denominator. Same thing. Reciprocal of sine is cosecant. Reciprocal of sine is cosecant. You have to remember that. It's one of those things that are just known among all mathematicians, okay? So these are reciprocal. So what's the reciprocal of A over C? C over A. Okay? So it's hypotenuse over opposite. What's cosine's reciprocal? Secant. So it B, C over B. You flip that B over C, you get C over B. Okay? C over B. Then cotangent is going to be the reciprocal of tangent, which is B over A. Sometimes, some textbooks write cotangent like CTN. Okay? So I need you to know that they're both abbreviations that you can use. 6 ratios for theta in the triangle below. What did I say about these angles? I like it when it's on the bottom right, right? But if you can figure this out with this angle just being where it's at, go for it. Some people just can't visualize it as quickly, so I recommend that you do this and redraw with the reference angle on the bottom right. Okay? Then the opposite to that is 16, and adjacent to that is 30. Then the piece we don't know yet is my hypotenuse. Right? So if we don't know a side in a right triangle, how do we find the missing side? Double the short one? Are we sure that that theta is a 30, 60, 90? No, we don't know that. It could be 31, and we can't use it. What is it? Pythagorean theorem. That's where that one comes in handy. Pythagorean theorem states if you take the two sides, squares of two sides, the two legs, sorry, and add them up, you get the same as the square of the diagonal, opposite to the 90 degree. Okay? So A is going to be 16 squared, B is going to be 30 squared, C is going to be my unknown, the part that I need to find. Okay, on your calculator, 16 squared, you should already have it memorized, but if you don't, use your calculator. Three squared is 9, 10 squared is 100, so 9 times 100 is, so 30 squared is 900. Okay, then we have C squared. Add these up, I have 56. Square root of 1156 is? Drum roll, 34. Isn't that nice? We have a nice whole number for my hypotenuse. So we need to use this reference angle of theta, okay? Sine of theta is going to be opposite over hypotenuse. Opposite is 16, hypotenuse is 34. But then what's the reciprocal to sine?
34.
Cosecant, which is 34 over 16. But, oh, Miss Bian forgot something. I just became an Algebra 1 student all of a sudden. Whoopsie daisy. What do you have to do? Simplify. 16 over 34 can be simplified with 2, so that's 8 over 17. And then the cosecant will now be 17 over 8. Leave it improper, just like so. Okay, ready? Cosine of theta. Cosine of theta is going to be adjacent over hypotenuse. What goes into both? So 15 over 17. Then secant is going to be 17 over 15. Tangent. Opposite is 16. Adjacent is 30. What goes into both? 2? Yeah, 2. Then we get 8 over 15. Is that simplified to its lowest terms? Yes, it is. So reciprocal tangent is cotangent. Game? Good luck. Okay? Now, if you're given a ratio, you could figure out the rest. That's the learning target that I'm asking you to be able to do. Okay? So if I give you one ratio, okay, of cosine theta, you should be able to find all the other 5 ratios of the same theta. Okay? So let's draw this. We don't know exactly what angle that is, so we're just going to put theta. But cosine of theta is 2 to 3. So where does 2 belong and where does 3 belong? So if this is 2 over 3, this is my adjacent over hypotenuse. So this is my adjacent over hypotenuse. Can I figure out the third side?
Yeah.
Yep, how do we do it?
A squared plus B squared
Which one's my A and B? It doesn't matter which one is A or B as long as they represent the legs around the 90 degree. Okay? A squared plus B squared equals C squared can be used, but C is always the hypotenuse, where these are the legs. Leg 1, leg 2. So does it matter which one we refer to as A or B? No. As long as it encompasses the sides that make the 90 degree, they're considered legs. Okay? So this is my unknown, so I'm going to put x squared plus 2 squared equals to 3 squared. And we get x squared plus 4 equals to 9. Then x squared must equal to 3. No, 5. I'm rolling my eyes. All right. And then x must equal to? Rad 5. So this is rad 5. Opposite to theta is going to be rad 5 over which one? X is equal to rad 5. Opposite to theta is going to be rad 5. So sine is going to be rad 5 over 3. Good job. Cosecant is reciprocal of that. So flip it upside down. But we can't just leave it there because we're not geometry students, we're algebra 2. So what do? Rad 5 over rad 5. And we get 3 rad 5 over 5. Okay. Is 3 over rad 5 wrong? It's not wrong. It's mathematically absolutely correct. Okay? It's just that as algebra 2 students who are learning trig, you should be able to rationalize the denominator. That's all. Okay? All right. If cosine is 2/3, then what's secant? 3 over 2, 1.5 versus 0.6, right? Okay. Tangent of theta is rad 5 over 2. Then cotangent is 2 over rad 5 or 2 rad 5 over 5. Rationalizing the denominator is going to get easier and easier the more you do it. Okay? So don't be too freaked out about it. If you could at least, if you're not sure how to rationalize it, but you just need help with this part, then just stick with this. That's your, like, far as you can get, then just keep it that way. Okay? Just be accurate. All right. So your homework or your practice, I'm giving you 2 options. Practice page for the first prerequisite part is page, this is 1, right? And then 2. Is this 3? Is this page 3? Okay, then it's on page 4. Prerequisite practice is page 4. This is your unit 7 prerequisite. Okay, PR. So I'm going to go back to my very first page. Oops, one more. And then I'm going to put page, did you say 3 or 4? I think I said 4, right? 4, number 11 through 16. And on Delta Math, I put it in as unit 7, prerequisite practice. Okay, so what I'm saying is this. You have a choice. You have 3 choices. You can do just the paper and be done with it, which I already have the answer key available to you. And if you've been doing it that way, perfectly fine, stick with it. If you have been preferring Delta Math because of the retake qualifier and you feel more comfortable doing that with tutorials and feedback that's given to you right away, do Delta Math. I made both. Third choice is doing both. A little bit of both or all of both. Up to you. You choose your adventure in terms of how you want to practice this. Okay? So 7-1 practice is going to be on page 3 and 4. Numbers 1 through 10. Okay? And then on your Delta Math, it's written as learning target 7.1 practice.